So let's take a look at this using equations. What's the percent yield of 60 grams of calcium carbonate is heated to give 15 grams of calcium oxide? We know that this is our actual yield. This number is not going to be used till the very last step of our calculation. First, we need to turn the 60 grams of reactant into the grams of product that we're interested in. Let's start by making a balanced chemical equation. Calcium carbonate decomposes. So carbonate's always decomposed in the same way. You get the metal oxide and carbon dioxide. Now I have to check to make sure this is balanced. 1 calcium, 1 calcium. 1 carbon, right there. 1 carbon. 2 plus 1, 3 oxygens. 3 oxygens. I lucked out. It's balanced. 1, 1, and 1. Easy balancing. So we need to do a mass-to-mass problem. We have started off with 60 grams of calcium carbonate. The first step is change grams to moles. The number of moles of calcium carbonate is equal to the number of grams, mass, divided by the molar mass. So the mass of calcium carbonate happens to be 60.0 grams. The molar mass of calcium carbonate happens to be 100.9 grams per mole. So that means the molar mass is 60 divided by 100.9, 0.5946 moles of calcium carbonate. I'm going to keep lots of decimal places as I go, and I'm going to keep the number on my calculator so that I can be as accurate as possible. Now that I know the moles of calcium carbonate, I need to change moles of calcium carbonate to moles of my product. Okay, these are the two I'm interested in, not really carbon dioxide. I realize this is a 1-to-1 ratio. You still need to tell me that you've done this. So I know that 1 calcium carbonate is the same as 1 calcium oxide. The ratio is 1-to-1. So I'm looking for 0.5946. And this is going to be x. I cross multiply. I get 0.5946 times 1 is equal to x times 1. Therefore, we have 0.5946 moles of calcium oxide now, whereas before we had moles of calcium carbonate. All right, are we done yet? No. Step 3. In step 3, we need to take our moles of calcium oxide and make it into moles of, sorry, not moles. I won't want moles, I want grams. I want mass. To get mass, mass is equal to the number of moles times the molar mass. So my moles is 0.5946 moles. And the molar mass of calcium oxide happens to be 56. I'll leave that up for you. So I notice I still have that same number on my calculator. It ends at 46 on my page because I'm too lazy, but I have all of the rest of the decimal number there. So I'm going to multiply by 56.08, and I end up with 33.3478. And I'm going to see if I can round. My significant figures in this case would be to 3, so why not 33.3 grams. Awesome. Of calcium oxide. Awesome. However, is this done? Well, this is the mass-to-mass problem, but what I've been asked for is the percent yield. To get the percent yield, we're going to use that calculation. Percent yield is equal to actual over theoretical times 100. This is our theoretical. In theory, we should get 33 grams. How much did we actually get? Well, we can only tell how much we actually got by doing the calculation. Sorry, doing the actual experiment. The actual experiment gave us 15. So, actual is 15. Theoretical is 33 times 100. 44.9. So we'll call it 45%. So that means we only got about 45% of what we should have.